So this next problem gives you an example of how to estimate percentages based on being given the mean and the standard deviation for a standardized sample. And they give you the fact that you are dealing with GMAT scores, graduate management admission test scores. They tell you the average is 547. They tell you to assume that the scores are bell-shaped, which means it's a normal distribution with a standard deviation of 100. So you can use the z-score calculation to solve this problem. And this is really a test of whether or not you understand the empirical rule. Let me demonstrate. So in the first problem, they want to know what percentage of the values are higher than 647. The next problem, they want to know what percentage is greater than 747. And then there are two problems that look at an interval. What percentage fall between 447 and 547? What percentage of the scores fall between 347 and 647? And they, of course, pick these numbers intentionally to make it easier for you to solve the problem using the empirical rule. So if we represent the distribution as a bell-shaped curve, my bell-shaped curves always look a little lopsided, with a mean of 547 and a standard deviation of 100. We can calculate the z-score for the first problem, which is x minus mu over sigma. Well, 647 is 100 away from the mean. Standard deviation is 100, so the z-score is 1. And you'll find that the other calculations work out to be similar. What they want you to remember is that if you go plus or minus 1 standard deviation from the mean, the empirical rule tells us that we'll capture 68% of the data values. If you go 2 standard deviations above and below the mean, you'll capture 95% of the data values. Now in chapter 3, they simply say if you go plus or minus 3 standard deviations above and below the mean, you'll capture almost all of the data values. When we get to chapter 6, we'll find out that it's actually closer to 99.7%, which is practically almost all. Okay? So for the first problem, if we go 1 standard deviation above and below the mean, we capture 68% of the data values, which leaves us 32% of the data values left. And because we're dealing with a symmetrical distribution, we have to take that 32% and split it between this upper tail and this lower tail of the distribution. So the number or the percentage of values that fall above 647 is going to be 16%. We take that 32, divide it in half. Half of that goes in the upper tail, half goes in the lower tail. So the answer to the first part of the problem is 16%. Likewise, if we look at the second problem, where we want to know what percentage of the scores fall above 747, we calculate the z-score, and the z-score turns out to be 2. So again, we know if we go plus or minus 2 standard deviations from the mean, we'll capture 95% of the data values, approximately, which leaves us 5% left. Dividing that 5% in half and distributing it in the upper and the lower tail, then we know if we go 2 standard deviations, which is where this 747 happens to fall, there'll be 2.5% of the data values. There should be 2.5% of the data values above that score. Entering those two values into the assignment, checking those are the correct answers. Now for the intervals, you use the same principle. I will show the interval problems in a second recording.